2.1, arithmetic and geometric sequences. Here we go. Kyler's going to read.
A.
Sequence. A sequence.
Is a function from the
Whole
numbers to the
real numbers. Keep going.
This means that we are only able to substitute
Very nice.
in whole numbers into a sequence, but we can get any real number as the output.
Go ahead.
Keep going.
Yeah.
As a result, when we graph the sequence, we will have points that we cannot connect. But we cannot connect them together to form a line or a curve.
All right, so a sequence is a bunch of dots, basically, and it's not a function. It is a sequence. Okay, so it's term by term, basically. So example 1, we consider the sequence defined. A sub n is equal to 4n minus 3, and we're going to find a sub 1 and a sub 7. So what do? We just substitute in. And so now we have 4 times 1 minus 3. So 4 times 1 is 4 minus 3 is 1. So a sub 1 is 1. Now we're going to find a sub 7. So all we're going to do is substitute in 7 for n. And so now we have 4 times 7 minus 3. So 4 times 7 is 28 minus 3 is 25. All right, keep going.
In this course, we will study 2 important types of sequences: arithmetic sequences and geometric sequences.
All right, sometimes I pronounce it arithmetic, but it is the same spelling as arithmetic. All right, so arithmetic sequences have common differences. All right, so successive terms have common differences, which is also known as the constant rate of change. And so to find our common difference, we notate it as D. And we take our next term, and then we subtract our previous term. Okay, so that's how we get our common difference. It's what's added from term to term. Okay, and so then formulas and equations. This is how you might have it in this year, and so it's formed in different ways. So a sub n is equal to our 0 term plus d, our common difference, times n. However, we're going to mostly spend our time with this function here. So a sub n is equal to a sub k plus d times n minus k. Now, the way that you were taught your other life in Algebra 2 was a sub n is equal to a sub 1 plus d times n minus 1. And that's how I used to teach it too until this course, but we don't actually care what the first term is all the time. We can take any term and then go from whatever term that is. All right, and so a sub 0 is our initial value. Our d is our what? Common difference. All right, because we add from term to term, so this is our common difference. And then our a sub k is actually called our kth term. All right, whatever that term is. Now, this side note's really good, actually. So arithmetic sequences behave like linear functions. So if you look at this equation, this is basically point-slope form. All right, this is kind of like our y equals y1 plus our m, because that's our difference. It's our constant rate of change. And then n, so that's like our x minus our value where we started. Okay, except they are not continuous, and so that's why it acts like a linear, but it's a sequence because they're just dots. All right, so let's look at the example with our graph. So we have a sub n is equal to 3n plus 1. Let's figure out what a sub 0 is. So what's my a sub 0? 1. There it is. All right. And so then my a sub 0 starts at 1. And now let's find a sub 1. And so what's a sub 1? 4. And so now I go from 1 to 4. And so then let's find a sub 2. And so what's a sub 2? 7. And so I go from 2 to 7. Now, again, if we just looked at it graphically, our common difference was our rise over our run, basically. All right, and so it rose 3 each time. All right, let's look at these examples on this one. So for each of the following, we're going to determine if the sequence is arithmetic, and if yes, let's find the common difference. On this first one, I'm going to list the terms, okay? And so when we list our terms, what's my s sub 0? Negative 3. What's my s sub 1? What's my s sub 2? 1. I'm going to do one more. What's S sub 3? 6. So my common difference from negative 3 to negative 2, what added? What did I add? 1. So I added 1. And then what did I add from negative 2 to 1? 3. So first of all, is it a common difference? No, we don't have a common difference. So is it arithmetic? No, this is not arithmetic. All right. What is it? What do we notice about these differences? What's the difference of my difference? This is 2, right? And so those things are constant, which means it's a what? Quadratic. Because my average rate of change is linear. All right, which means it's quadratic, but it's a quadratic by just looking at it. All right, so let's look at this next one. I'm going to substitute in values to try to prove a point. And so let's substitute in 0. So when we substitute in 0, what do we get? 6. We substitute in 1, what do we get? 4. How about 2? 2. How about 3? 0. All right, and so then what's going on? What's my common difference here? So 6 to 4 is what? Negative 2. And then what? Negative 2. And then what? Negative 2. So is it kind of linear? Is it arithmetic? Yes. All right. C. It's arithmetic, and so what's my common difference? Not 2, but negative 2. All right. So we're adding negative 2 each term. All right. But really, you can just look at it. Because common arithmetic sequences act like a linear function. Is this a linear function? Is this a linear function? Yes. And so my common difference is basically the slope of it. And so my slope here is what? Negative 2. All right. So we really didn't need to list out these terms if you actually know how they work. All right. Now this one's term by term. So what do we need to do? We go from negative 7 to negative 2. So what's my difference? 5. Then what's my difference? 5. Let's do it again. And then what? 5. Are they all the same? Yes. So is this arithmetic? Oui. All right. And so what's my difference? 5. All right. Pretty good. Cool. Let's do it again. So 1 to negative 2. What do we got? Negative 3. And then negative 2 to 3. 5. I can kind of stop there. Is this a common difference? No. So is it there arithmetic? No, dog. All right. Pretty good? Cool. We are moving. All right. So let's look at this one. Kyler's going to be my reader. Keep going.
Let A sub n be arithmetic sequence with A sub 3 equals A and B equals -3. Find an expression for A sub n and use the expression to find A sub 12.
All right, fantastic. So we are given our third term, technically kind of our fourth, and then our difference is -3. And so now we just need to build our A sub n. So A sub n is equal to, I'm going to start out at this term right here. So I'm going to start out at 8. Plus, what's my common difference? -3. And then it's times n minus, what term was it? My 3. And so now I have n minus 3. And so we don't actually have to go back to A sub 1 like we did in years past, okay? It's just basically point slope form. This is my y value, and then this is like my x value in which we used it at, all right? And so now we're going to find A sub 12, all right? And so when we find A sub 12, we just substitute in 12. So now I have 8 and then minus 3 times 12 minus 3. And so what's 12 minus 3? 9. 9 times -3 is? -27 plus 8 is? -19. All right. All right, let's look at example 4.
Let A sub n be an arithmetic sequence with A sub 2 equals 7 and A sub 6 equals 9. Find an expression for A sub n and use the expression to find A sub 12.
Love it. All right, I'm going to show you 2 ways to Tampa here. We're going to find A sub n and A sub 24, okay? Just like before. However, what were we not given this time? Our common difference. So guess what we need to find? our common difference. Now, I'm going to show you one method first that I don't really care for, and then I'm going to show you my method. Sound good? Cool. All right, and so this one, if I go from 2 to 6, which one's bigger? Which one's my last term? 6, okay? And so my a sub 6 is actually 9. Does everybody agree with that? And so then I need to start out with my second. So then I go at 7 plus my common difference of something. And then I'd have 6 minus 2 because I used 6 minus 2 terms. All right? And so then 6 minus 2 is how many terms? 4. And so then I would end up having 9 is equal to 7 plus 4d. And so how would we start solving for d? Subtract 7, so then I'd get what? 2, and then I'd divide by 4. So d would equal 1/2. All right, that's one method to use. However, this is the way I work with arithmetic sequences. All right, so what's my difference from 7 to 9? 2. All right, so sometimes I write it out like this. And so when I work with it this way, so my difference between 7 to 9 is 2. And then my difference between 2 to 6 is what? 4. And so then it's like my y2 minus y1 kind of thing. And so it's really like 2 over 4, which is what? 1/2. All right, and so that's how I usually do it in my noggin. Right there. However, if you want to work with like your a sub k, that's how we did it on the left. Do you see how they're actually the same thing though? All right, so honestly, I don't care how you go there. However, pick one. All right, and so now let's build our a sub k, or our a sub n. All right, so our a sub n is equal to, does it matter which one I use, a sub 2 or a sub 6? Does it matter? No, which one do you want? I do the 6 one too because it's closer to 24. All right, and so I'm going to say 9 plus, now what's my common difference? 1/2, and then I need to say n minus what? 6, because I'm using my a sub 6 here. All right, and so if you were to use your a sub 2, it would be the 7 and the 2 instead of the 9 and the 6. All right, so there's my a sub n. And then what do we need to do? We need to find a sub 24. And so now we'd have 9 plus 1/2 times 24 minus 6. So 24 minus 6 is 18. 18 times 1/2 is 9. 9 plus 9 is 18. All right. Pretty good? All right. So on example 5, now we're given a graph, and we need to find this arithmetic sequence and find a sub 17. All right. So let's look at our little graph. Okay, so I start out at 0, 8, and then I go to 1, 6, and then I go to 2, 4, and so forth. So what is my common difference? Ella, what's my common difference here?
Is it 8?
No. I go from 8 to 6 to 4 to 2. -2. So my common difference is -2 here. All right. And so now I need to write an expression for a sub n. And so now a sub n would equal, does it matter which one you pick? No, I'm always going to pick the one with 0 in it every single time because I don't have to think very often. All right, and so then I'm going to start out at 0, 8 basically. So I'm going to start out at 8, and then my common difference of -2 times n minus what? 0. All right, you don't have to put the minus 0 part. However, I'm going to explicitly show it here. All right, and so now we're going to find a sub 17. And so when I substitute in 17, I have 8 minus 2 times 17. So 2 times 17 is 34. So 8 times -34, or plus -34 is -26. Good job. All right. All right. Ella's going to be our reader for geometric sequences now.
Successive terms have a common ratio or common proportional change.
All right, beautiful. So this one we're going to find a common ratio. And the way we find our common ratio is it's proportional. And so it's our next term. So it's our a sub n plus 1 over our a sub n. Okay, so it's our next term divided by our previous term. And that's what's being multiplied from term to term. Okay, so this is a common ratio. All right, so our formulas and equations, I'm just going to kind of flat out say it first. The one that you guys were accustomed to is with a sub n was a sub 1 times r to the n minus 1. That's what you guys used a lot last year in your Algebra 2 class. All right. However, this is the one we're going to use now. So this is when it's our zero term or our initial value. However, we're going to kind of play around with this one because it can happen at any term. Instead of just one, it can be at any term. Okay, and so this is the one we're going to play with the most. All right. So g of 0 is what? G sub 0 is our initial value. Our r is our common ratio. All right. And then our g of k, it's kind of weird, is our kth term. All right. And so before arithmetic sequences kind of modeled our linear function, geometric sequences model our exponential functions. What is an exponential function? So what makes an exponential function? The variables in the... Very good, guys. Very good. All right. So let's look at this one now. All right. So now I have g to the 1/2 to the power of n. All right. And so let's substitute in our numbers just like before. So what's g of 0? 8. And so now I start out at 0, 8. And then what's g of 1? So 1/2 to the power of 1 is 1/2, and then times 8 is 4. So g of 1 is 4. And then let's find g of 2. So g of 2 would be what? Somebody said it? No? 2. All right. Because we're multiplying by 1/2 each time. And so then g of 3 would be what? 1. All right. And I'm going to go one more. And so g of 4 would be what? 1/2. All right. I'm not trying to fit another one in there. So we're going to stop there. All right. But if you were to have to go backwards from a graph, you take your next term, divide it by your previous. All right. And so you'd have 4 divided by what? 8. And so that would find my common ratio to be what? 1/2. It's 4 over 8. All right. So it'd be our next term divided by our previous. All right. So again, geometrics model a what kind of function? An exponential. What's an exponential function? When the variable's in the exponent. Fantastic. Great job. All right. So let's look at A. So could that be a geometric function? No, it's not. It's not a geometric sequence. So it's not exponential. So that's a no. That's a no. All right. So let's look at B. Yes. Is that a geometric sequence? Yes. I don't even have to go term by term. That's a geometric sequence because it models an exponential function. So so what's my common ratio? 2. My ratio is 2. All right. This is a list of numbers. So now I need to figure out what we're multiplying to get from term to term. And so now if I go from 1 to 3, what's being multiplied? 3. So this is times 3. And then how about 3 to 2? What am I multiplying by? 2/3. All right, because you take your next one divided by your previous. All right. And so are those the samesies? No. And so is this a geometric? No. Let's look at this next one. So now I have 16 to -8. So what's it being multiplied by? -1/2. All right. Again, the easy way to do it is like do -8 divided by 16. You get -1/2. And so then -8 to 4. -1/2. How about 4 to -2? -1/2. So is that a geometric? C. All right. And so what's my ratio? -1/2. All right. All right, cool. Example 7. Who's my reader? Go.
Let g of n be a geometric sequence with g of 1 equals 12 and r equals 2. Find an expression for g of n and use the expression to find g of 4.
All right, fantastic. So let's build our g sub n. All right. Do we have everything we need? Do we have a term and a ratio? Yeah, so we're ready to go. So a sub n would equal what? Where do I start out at? 12, and then my ratio of 2, and then n minus what? What term is this? G sub 1. All right, so my a sub n is equal to 12 times r to the n minus 1 there. All right, and so now what do we need to do? We need to find g of 4. And so I'm going to find g of 4 by just substituting it in. So now I have 2 to the power of 4 minus 1. Well, what is 4 minus 1? 3. 2 to the power of 3 is 8. 8 times 12 is 96. Very good, guys. Very good. All right, so we got 96 for our a sub 4. All right, and now let's look at example 8. Go ahead.
Several terms of the geometric sequence g of n are shown above. Find an expression for g of n and use the expression to find g of n.
All right, fantastic. So what do we not have here? My common ratio. All right, so we need to find our common ratio. So how do I get from 8 to 4 to 2 to 1 and so forth? My ratio would be what? What's being multiplied? 1/2, exactly. All right, and again, the easy way to do is like do your next term divided by your previous. So like 4 divided by 8 is 1/2, and then 2 divided by 4 is also what? 1/2. So that's the way you should kind of think about getting that ratio. So now let's build our g sub n. All right, so our g sub n would equal, does it matter which one you pick? No, not really. All right, I always like to pick the one with a 0 in it, but you don't have to. So I'm personally going to pick that one. All right, so let's do that one. And so I'm going to start out at 8, and then times 1/2 to the n minus what? 0. And that's why I pick it, so I don't have to think as hard. All right, and so now, after we build our g sub n, now we find g sub 10. All right, because that's what it asked for. And so now we have 8 times 1/2 to the power of 10. Sometimes we need to math frac it after we put it in, and this one ended up playing nice to be what? 1 over 28. 128. All right, so that one played nice after I could math frac it. However, I'm still recording this for the sake of some people. Work with the numerator and denominator separately, okay? And so what I mean by that is if it didn't math frac very nicely, do it like old school. So you do like 8 and then times 1 to the 10th power. And so you'd end up with 8. And then do the bottom separately. So then you'd have 2 to the power of 10. And so then you'd put in 2 to the power of 10 separately and you get 1024. And then from there, put that in your calculator and then math frac it. Okay? And so sometimes the calculator won't math frac things depending on how large they get. And so that's the way to do it. Work with the numerator and denominator separately.
This is 2 to the power of 10.